Welcome to the online class BSc 4th semester diffraction session 4. In this session we learn zone plate and differences between zone plate and convergent lens or simply convex lens. So first, zone plate. A zone plate is a specially constructed screen such that light is obstructed from every alternate zone. The construction of the zone plate is based on the fact that the areas of half-period zones are equal. The radii of half-period zones are proportional to the square root of the natural numbers, and if the light is obstructed from alternate zones, the intensity of image is sufficiently increased. Construction. A zone plate is specially constructed screen having alternate concentric, transparent and opaque zones. There are two alternatives. The odd numbered zones are covered with black ink, then a reduced photograph is taken on a glass plate of uniform thickness. In the developed negative, the odd numbered zones appear transparent to incident light and the even zones appear black. The glass plate in this case called as positive zone plate. The drawing appears as shown. The even numbered zones are covered with black ink and a reduced photograph is taken on the glass plate of uniform thickness. In the developed negative, the odd numbered zones appear opaque and even numbered zones are transparent. The glass plate in this case called negative zone plate. The drawing appears as shown. The correctness of Fresnel method in dividing a wavefront into half-period zones can be verified with its help. Action of zone plate of an incident spherical wavefront. Let xy represent the section of zone plate perpendicular to the plane of the paper. S is a point of source light. P is the position of the screen for a bright image. Small a and small b are the distances of the source and the screen from the zone plate respectively. OM1 is equal to R1, OM2 is equal to R2, etc. are radii of first, second and etc. half period zones. The position of the screen is such that from one zone to the next there is an increasing path difference. The areas enclosed between these circles are known as half-period elements or half-period zones. The Fresnel zones are the annular rings in the wavefront with the waves from corresponding points of adjacent areas differ in path by half wavelength. The area of the first circle of radius PM1 is called the first half period zone. The area of another ring M1, M2, M2, M3, etc. are known as second, third, etc. half period zones. The amplitude of the wavelet at the point O depends on the following factors. The amplitude at a point at the point O is directly proportional to the area of zone. The amplitude falls off inversely as square of the distance of the zone from the point O. The amplitude varies with the obliquity of each zone. It is measured by equation 1 plus cos q divided by 2. The amplitude decreases with the increase in obliquity. This decreases is extremely slow but steady. Comparison between zone plate and a convex lens. First, we see in zone plate. The zone plate form a real image of object and the equation connecting the conjugate distances are similar. And second point, the focal length are inversely proportional to the wavelength lambda and hence suffer from chromatic aberration. And point third, in zone plate, the chromatic aberration in a zone plate is more severe than in a convex lens. Option 4, the focal length is greater for violet rays than for red rays. Option 5, it acts simultaneously as convex lens as concave lens. In addition to real image, a virtual image is also formed simultaneously. Option 6. The image is formed by the diffraction phenomenon. Option 7. It has got multiple foci on either side of the plate, hence the intensity of the image formed will be much less. Option 7. Waves reaching the image point through any two alternate zones differ in path by lambda and in phase by 2 pi. Option 8. A zone plate can be used over a wide range of wavelengths from microwaves to X-ray. So here in convex lens we see point 1. The convex lens forms a real image of the object and the equation connecting the conjugate distances are similar. Option 2, point 2. The focal length are directly proportional to the wavelength lambda and hence suffer from chromatic aberration. Point 3. The chromatic aberration in a convex lens is less severe than in a zone plate. Point 4. The focal length is greater for red rays than for violet rays. Point 5. It forms only a real image. Point 6. The image is formed due to the refraction of light. Option 6. Option 7. It has only one focus as all the light is focused at one point. The intensity of the image will be more. Point 8. All the rays reaching the image point have zero path or phase difference. Point 9. Glass lens cannot be used beyond the visible region. So here question 1. The construction of the zone plate is based on the fact that the area of half period zones are equal. Option B. The radii of half period zones are proportional to square root of the natural numbers. Option C. If the light is obstructed from alternate zones, the intensity of the image is sufficiently increased. Option D. All of the above. The answer is option D, all of the above. Question 2. The radii of zones are proportional to even through area of the each zone is. Option A same, option B different, option C both A and B, option D none of the above. Answer is option A same. Question 3. Zone plates are used for dash range. So option A wide range, option B short range, option C only for 100 meter, option D none of the above. Answer is option A wide range. Question 4. The image is formed in zone plate by the phenomenon of option A reflection, option B refraction, option C diffraction, option D all of the above. Answer is option C diffraction. Thank you.